Okay, then let's open up that little app. Stuff there. Right. All right, so I didn't have time to write the review out for you guys, but we'll just kind of, so everything I do on the board is exactly what we would have done for the review anyways. So just kind of copy that down and that'll be your review. And I also sort of decided when I this is, so you guys will rejoice. There's just a lot of material that we've gone over because we started with solving, solving equations where you had to factor, and then we did quadratic function, did polynomial and rational. And I'm just looking at it. We're not, so on this test, you're not going to see polynomial and rational. So that's the rejoice part. You will see it on the final though. So I mean, it's part of the class. You're going to see it on the final. So when we get back to the final, we'll go over it again. But it was just going to be way too much to include. Kind of tested it out with the last class that was did when we were reviewing, and yeah, it's going to be way too much to include all of that stuff. So we are only going to look at basically factoring and factoring to solve, basically factoring to solve, and we're going to look at quadratic function stuff, and that's all we're going to look at for this test. So make sure, hold on, make sure my audio is working on this. Yeah. All right, so that means, for instance, in a couple of these set up, let's do squared minus 4b minus 12 equals 0. And then let's do something like this. Not predictable. And, something like this. So the first two we'll look at. And I'm going to ask you to solve something like this. So first off, really quick, what do we know about solving? So solving overall, we know that when we solve an algebra, you either get the variable by itself, or you're going to get everything on one side as factor, set those factors equal 0. Which type of solving are we looking at? Getting everything by itself or factoring? Factoring. Yeah, and how can you tell that's factoring? Saying
Alpha no x to y plus equal to 0. So
yeah, so one tell is if you have equals to 0, although we'll look at one later where actually you end up not having to factor it. So almost always, yeah, that's actually a good tell. But what was the other? So I kind of, for like 2 weeks, I like every day said like there was one particular tell that lets you know whether you factor or not. Do you guys remember what that was? Because it's just a better tell. So trying to get you guys to, I'm trying to brainwash you guys into this because it's a much better tell than all the other tells. So key is actually not necessarily the 0. But the fact that you don't have like terms, so you guys remember me saying that like 50 billion times, if you don't have like terms, then you factor in, yes. So, honestly, I don't do that stuff to annoy you guys. I promise you guys, the things that I'm saying like that, where I say it 50 billion times, I really am trying to brainwash you that that's a better way to think through it. So sometimes you just gotta basically let me, let go and let me give you a better way to think through, a better key or a better flag to think through the stuff. So that really is the key. If you see, like terms, factoring is gonna be your only way out of that. It's talk about a little later if you can. But this factoring is your only way out. So that's what you're gonna need to do here. So I wanna give you guys a little bit of time, at least 5 minutes, to work as much as you can through those two equations, solving those, and then we'll go over them.
Well, the first one was like, that was 46.
I have a pen.
This is what I mean. My class don't work. It's a 96 one for the first. Like this.
That's a 4-1.
Or
Or
for the first one.
for the first one, it's a 4.
For all four of the, okay.
Yeah. It's good.
Like 46 and something. Wow. Oh, yeah. Yeah. I come out of unloaded, like, half tired. Bro. Mhm. Mhm. It's not kind of minus. Oh.
That's. Oh, it's out. Yes.
Oh, it rains. What's my thing? That's it is not. And let's see, statement. I was going to listen. And building signaling keys. Oh, I'm sorry. Yeah. I'm using cat. Look, okay, my notes is not the best, I just do it, so. Um, so, it's the cat method. No, it's fine, but look, so like, so you do it by itself, right? Because this one's just like it's by itself. So what X to the X and X, right? Which you do the what times each other or plus each other add. What times when it gives you that probably add when they give you negative? It's like a plus. Oh. Yeah, negative 6 plus 2. Yeah, that's what I was saying.
Yeah.
Yes,
Yeah.
yeah. And then lucky codes. I was still thinking. I think it's that. I'm like, right, that's what I'm thinking. Because negative six, that's two negative, negative 6 plus 2, and then negative. Hey, you don't keep trying. You feel smaller. Watching it's not that. Watching the it's not that. Yeah, no, that was. Oh wait, no, it's three. So go that's it. That's left here. Not. I went one. Yeah.
No, I don't know anymore.
No, yeah, I mean, it's right, but I'm not telling you any dots on it. It's just drop pretty. Um, it's fucking
On your own. So starting with one, we already have it equals 0, so really you just have to go factoring here. And the first thing to check with factoring is if you have a common factor, is there a common factor for number one? Or just what did you guys take with factoring? Yeah, So this is a two parentheses, cat method, whatever you want to call it. And what you end up getting. Just say it again, and it's not you, it's my fault, this is loud, my ear hurts. Yeah. So b times b there, which will give us the b squared, and then if you do +2 minus 6. I'm just showing you kind of how the factoring works, but you don't have to write any of that in. But b times b is b squared. 2 times -6 gives you -12. Then you have to check the middle parts of the distribution. So 2 times b, 2b, b times -6, -6b. Then you combine your like terms. That gives you -1. This just all checks that this is the correct way. Good, and then once you have that, that's to solve. Yeah. Well, so once you have this, then how did you solve for b? Yeah, perfect. So b plus 2 equals 0. 6 equals 0. And that's what you get. Yes, you got it. So subtract 2 from both sides, or you can probably see the solution. You don't have to write that if you don't need to. B equals -2. And b equals 6. There are two solutions to that. What about on the second one? Where do we start then? Yeah, so the first thing is notice you don't have the 0. We need the 0 so that once we factored it, we can set it equal to 0. So the first thing is get rid of this 15. That just means you're moving it to the other side. So that we're gonna have 3y squared plus 4y minus 15 equals 0. And then you had to factor from here. So this is another one. There was a common factor, but 2 parentheses was going to work on this. What are the factors in the on this?
Yeah.
Yeah.
It's all over.
The last class before y'all had a good question and a good point that we kind of emphasized that just again, be comfortable with the fact that, so I'm writing this up here, somebody said it's the right answer, and I'm gonna show you why it's the right answer, but you're not gonna see it right away, especially on something like this. Once you have a coefficient in front of y squared, I guarantee you, again, we want everything in life to be like, I can just see how to do it, write it down, move on to the next thing. This is a part of mathematics that it is trial and error. You will not see the centers likely. And that's okay. So you just have to, what I'm trying to say is be okay with this being trial and error. So you're gonna pick 3y times y, because that gives you 3y squared. And then you're gonna pick factors of 15, but you're probably gonna put them in the wrong place to begin with, or you might even have the wrong factors of 15. Use your results to tell yourself it's gonna keep moving on the right combination. So the right combination though ends up being -5 here and a +3 here. -5 times 3 is -15. Then -5y plus 9y, so I'm just doing the other parts of the distribution there. That gives you the 4y that will. This is the correct way to factor this. Then you put down what 20. Yes, 3y minus 5 equals 0. We have 5. 3y equals 5. And then divide by 3. Y equals 5/3. Minus 3. Y equals minus 3. Good. Any questions, not just this one, but these first two to begin? Both of these, we're doing the two parentheses method of factoring, but I really want to emphasize that's obviously not the only factoring you're going to see. I'm probably just not going to have grouping on the test, but just know that that's part of the game. So again, when we get to the final, I guarantee you're going to see one problem where you have to factor by grouping, guaranteed. Not because I've even seen the final, but because that's the whole sort of definition. The final tests you over everything. And so it's not that you're going to see everything, but it's going to test you over all the ideas. So you will see factoring by grouping once. But so when we get to the final, we'll look at that again. But for this test, I want to focus more on this. We can see something like this: 2x cubed plus 28x squared. It's 6x equals 0. And so we want to, same thing, we see that there's not like a term, so we know we're factoring. But notice here, so on this, first thing, I'll give you guys a couple minutes to work, but the first thing I want you to do is what do you call it, look for a common factor, see if there's a common factor that you can divide out. So start there. And let's see where you get on the problem. So I'll give you guys a couple minutes to work on this.
What are these all? Is it?
What's
They don't move. They have 16 more words. Okay, so we're trying to be like 3 ends of it. Oh, 4. Wait. Ooh. Okay. Two. Fourteen. Okay. All right.
We're gonna follow that. To one more map, but you'll get right, but not a number, so the two is perfect. There's background of two, what else do they have in common? X, so background to it is. And what does that leave us with?
I think 14.
So we get, first we're gonna get x squared,
Yeah.
lead part, two x times x squared is two x cubed, and then yeah, you go on 14. The two x times 14 is, or 2 times 14 is gonna be 28, x times what gives you x squared. And so this will be 14x. And then 2x times what from the 96x?
48.
48. Yeah. All right, good. So that's your confidence. And so when we go to solve this, this is one of your factors. Even though it's not in parentheses, this is one of your factors. So this is one of the things that's going to give us a solution. Then you got to look at the rest of this and basically look to see if you can factor that part. Sometimes you can't, but sometimes you can. And there's honestly not a good tell on whether you can't or can't. So once you see this, it's just auto, you want to try to factor it and be okay with trial and error. If it doesn't factor, that's good. But if it does, on the next step. So this does factor into two parentheses. And what did you guys get? Yeah, those can be, end up being x plus 6, that's x plus 6. So now we have three factors. And yeah, these are as simple as they're gonna get, so now we can set them equal to 0, we can solve, so 2x equals 0. X plus 6 equals 0. X plus 8 equals 6. So what are the solutions? If this was an x plus 2, you'd be exactly right. So let's look at that really quick because that's a really good point to bring up. If this is x plus 2, that is a -2, but this is 2 times x. So like when you're solving this, you're getting x by itself. Instead of subtracting 2, what do you do to get rid of the 2? You divide by 2. It's not even that. I mean, what is 0 divided by 2?
Yeah.
Just a 0. So it's actually just going to be 0. But then on the second one, we subtract 6 to get rid of plus 6. So that's x equals -6. And we subtract 8 to get rid of plus 8. So that is -8. 0, 6. or -6, sorry.
This.
Any questions or any issues there? So let's look at a couple problems to emphasize, well, one, just a couple problems where I want to emphasize that you don't always factor. Sometimes because there's a simpler way, sometimes because you can't factor. So let's also try to solve, let's do negative. And 27. So taking a look at this, it has W squared. But maybe what's different about it compared to all the previous ones? Well, yeah, so yeah, we haven't seen a negative, say it again.
It's just one term. So
It's just one term, but the bigger issue is it's just one term. So again, going back to what we said at the beginning of the review. If you have not like terms, you have to factor. There's no other way at it. But notice here, there's just one term. Which means we could get W by itself. So you don't have to factor this because there isn't another piece that's not a like term. So you could just get W by itself. Technically, you could factor this if you want to, but honestly, it'll be more time and effort than just getting W by itself. So that's just the little thing to recognize on this one. So I'm not saying if you see this on the test and you go ahead and auto factor it because you're factoring everything else, that's fine. You're still gonna get the answer. It's just gonna take you more time and energy and effort at it. So that's just, once I see just the W squared, I can just get W by itself. So I'll give you guys a couple minutes to see if you can get W by itself.
Yeah, that's how. Whenever you want to. Bruh.
All right. So how do you solve this?
First, divide, check.
So and did you go to factoring from there? Okay, so I'll highlight your second. We'll go back and deal with factoring. But I want to highlight, you don't have to that. We can just divide by -3. So again, you just go back into regular equation solve. You're just trying to get the variable by itself. You divide by -3. But again, the only reason we can do this is we don't have, like you said, another term with the W. But yeah, and then what do you get? Yeah, so I think the only thing you consider should be -9, which will affect the instance slightly. But the next thing to do, what's just saying, is we gotta get rid of the square, and the way you do that is square root. Square root is the opposite of squared. I'm gonna take the square root of W squared, so those cancel. I'm gonna take the square root of -9. And when we take the square root, there's always two different answers. So for instance, the square root of 25 is 5, but it's also -5. It's -5 and -5 is still 5. So when you take the square root, you always get two possible answers, positive and negative. But when you're taking the square root of the negative here, so we're gonna have W equals plus or minus. So the difference here, if this was a +9, then what would my answers?
Plus or minus.
Yeah, 3 and -3. But if this is a -9, we figured out that, so classically we can't take the square root of negative, but we actually can. So what do we get when we take the square root of negative?
Plus or minus imaginary.
Yes. So just remember that, so one way to think about this is we can think of -9 as -1 times 9, and the square root of -1 has an answer. Square root of -1 is the imaginary number I. So this is gonna be square root of 9 is 3, but then square root of -1 is 5, so this is gonna be plus or minus 3 I. And you can leave it like this, but just remember that we're really talking about 3. Positive 3i. It's only for the square root.
Oh, so
Yeah, because it was negative, yeah. Actually, I think I will, just for the sake of time, so again, you can go back, you can do this pattern, but I don't want to emphasize this. For now. If you look at this though and you want to factor, like I said, go ahead and factor. You're still gonna get the same answers. So like I said, so there's sometimes you don't need to factor. There's sometimes you can't factor. So let's say we had something like look at something like x squared minus 5x minus 8 equals 0. Notice, does this look any different than the first three problems really, or especially the first two? So the first thing I want to emphasize about this is you're not going to know that you can't factor it until you try to factor. Again, that's just the nature. So trial and error is the nature of like this part of algebra. So we're really, just to give you that in a minute, let me try to factor this. This kind of confirms ourselves that it doesn't factor. All right, so yeah, it was as prophesied, as for scripted, no, but doing the factoring, does anything work there? One and eight, born through our own ways to multiply those combinations. So it can't be factored. If it's a square, it's still, you can still solve it. So if this was a cube, we could, at least especially for where we get in this class, we can't solve it. Fourth power, we can't solve it. But if it's a squared and we can't factor it, we can still solve it. So what's our tool? What's our way to solve squareds that can't be factored? Say it again. Yeah, negative b. So the quadratic. So as long as it's squared, we can still solve this by doing negative b plus or minus square roots b squared minus 4ac all divided by 2a. Call it the quadratic formula because it solves quadratic equations. When you're doing this, so looking at this, a is always the number in front of x squared, the coefficient. B is always in front of x. C is always the number on screen. So once you have A, B, and C identified, though, this is plug and chug. Calculate and simplify. So usually do. So let me give you guys a couple minutes to plug those in and kind of work that solution. Yeah. Alright, what y'all are getting. So what did you plug in for B? So that means on the outside here, that negative in front of the B is not part of the negative you see there, so that's an extra negative, so it's negative, -5. Plus or minus -5 squared. It's 4, what's A? 1, what's C? -8. 1. And someone take me to the calculation.
I did 2 times.
Okay, yeah, so kind of working this through. So honestly, this is one of those where, order of operations is always the same, but since you have so many things, so many pieces in here. Yeah, we're gonna essentially do the square and we're multiplying all this time. Just list it separately. So you're right, so 4 times 1, -4 times 1 times -8, what did you get for all that? That should be 32. What about the -5 squared?
Positive.
Positive 25, and then this -5, we're turning into a +5, so this would be 5 plus or minus. We're at 25 plus 32. Over 2. And then what do we do from there?
Add 5.
It's a 5 plus or minus the square root of 57 over 2. And then could you do any simplifying or anything from there? So this one, it ends up no. There is a way to divide 57 surprisingly 3 times 19 would be 57, but I can't take the square root of 3, can't take the square root of 19. So when you're simplifying the square root, again, you're not just, it's not that you're looking for like any factors, like can it be factored, but can you find factors that you can take the square root? In this case, you couldn't, which means this is all there is. So that's our 2 solutions. 5 plus that number divided by 2, 5 minus that number divided by 2. Yes. That's when you're doing the graph.
Alright.
Good question. Any other questions? All right. Then, yeah, let's look at the rest of this test is gonna be graphing. You'll notice actually not only all my tests, but really all the tests you're getting in algebra are basically either gonna be solve this thing or graph this thing. So after we worked on this, we looked at graphing, quadratic functions. So I'm just gonna focus on that. So like I said, I'm not gonna put polynomials, rational functions on tests. We'll re-review it. But what we are gonna look at is I'm gonna ask you, so these problems with quadratic functions, I'm gonna ask you to graph it, but you guys already did it for the first test, so that was nothing new. And I'm gonna ask you then to list the x-intercept, the y-intercept, domain, range, x-intercepts, y-intercept. And then the two new things with quadratic functions, something like this, is you have a vertex and you have an axis of symmetry. So for instance, copy the same problem. Something like this. So I'm gonna ask you to graph and find all that stuff for negative x minus 2 squared plus 3. So like we talked about, I think we actually spent about a week and a half on problems like this. But like we were talking about there, the first part of it, again, graph, domain, range, even we'll talk about definitely y-intercept. That was all the first part of the class, x-intercept too. You guys know how to do that, so that's not anything new, and you want to treat it that way. So when you look at this problem, you don't want to think about, oh crap, what was that problem I did and how did I do it? Like this is English for you guys by now, or at least this is rote for you. So, when we were talking about it in class, again, the homework kind of put it backwards, where it had you find all this stuff first and then get a graph going. And it's just because of the way graphing is programmed in these homeworks, you kind of can't do graphing by hand. You can't do what we really do in class, and so they have to do it in reverse. What I want you guys to do is I want you to do exactly what we've done in class. So I want you to graph first, and then you're gonna have you're gonna be able to see almost all this other information. So that's actually the first thing I want you guys to do with this is don't try to remember how to do this. You know how to graph. Go ahead and graph this first, and then write as much of this information as you can see from the graph. So take some time to do that. Scanner. All right.
Michael. Mm. Like, I wish you wanted to out. I'm saying, you like it's like this four, times four, eight, and then plus three. Six. What do you six? Plus, here's. What did you want? What did you want? Plus three. Mm. Yeah. Cool. Mhm. There's a bunch. Probably, but you. Mm. There you go. Mm. Very good. Mm. 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 Really. Yes. We don't document that. Really breathing. Then breathe. Really breathing. God, this was on the Chinese man.
Yeah, so like this, and this should be.
She.
What was that?
Probably specifically. Well, let's be careful. Something.
So we just type, you type this without, just like, same thing. Yeah, negative, and all that, that'll get you to the right.
Okay.
I think that's probably what's happening. This is how you're doing. Then that's what's happening. It's just so school. It's bad. Okay, all right, well, let's look at this.
Oh, there's two.
Uh, So to get a graph going, what do we do first? Yeah, table, and what were you saying? Just pick. Yeah, just pick X. So we get a table going, you're just gonna pick some X values. And this is the thing, again, I know I'm really a broken record on this, but I still see some of you just, I promise you, you just don't trust that this is the way to do it. So I still see some people put the table on the paper and then you do nothing from there. And I know you guys better than you think, or that, that to know that you guys, like you've watched me do this, actually at this literally at this time, you've probably seen me at least do this 30 times so far this semester. It's not that you don't know how to do it, you just really don't trust that you can just pick the X values and plug them in. That's the first hurdle to get past. Please just pick X values and plug it in. That is how you graph. You have to literally brainwash your head for that. So then every single time you graph, you're gonna do the same thing, and that is what you're supposed to do. Every single time you graph, you're supposed to pick X values and plug them in. So somebody give me some of the X values that. You did -1 through 4. Yes, let me get that's correct. That's gonna be the quickest way there. What else did you guys pick?
In the regular.
Okay. Well, let's start
See where we're at.
just to see where we're at. So let's start with the regular and then we'll see why we end up going up to 4. And I'm doing this especially because I know where most of y'all are in this class as far as graphing. And this is where you are. So let's start with -2 through 2, and then if we need to add more, we'll add. So when you plug in a -2, what do you get? Say it again. Let's see. Oh, yes, +3, so it is gonna be -13. Yes, good, good. What about -1? -6? What about 0?
Negative one.
It'll. Sorry, I'm moving it on. Say it again. -1, yes. 1,
Two,
2, and then 2
three.
gives you a 3. So let's see where we're at and see why we need to pick some more. So let's graph that part to begin with. 13 is gonna be a little too big, but the rest of this is fine, so. It's 1, 2, 5, 6. 6. -1, -6, 0, -1, 1, 2, and 2, 3. This is what we have so far. How do we know that we need more? Because it's only one side. So at least you know that a square looks like a parabola. So again, you know what this shape is going to look like. Again, that's something you should have memorized from the first part of this class. So those basic functions, please, 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 those pictures should be embossed in your head. You know this is a parabola and it looks like we only have 1/2, so we need to get some of the right side. So that's why let's pick 3 and 4. Yeah, 3 will give you a 2 when you plug it in and do the calculations. 4 will give you a -1. You can draw graph. So once we have that, so just again, just like the first test, so I'm gonna basically grade one part of the grade for this problem in the graph. The second part is the rest of the study. So let's do domain. What's the domain gonna be? Yes. What's my range gonna be? Yes.
Oh, bracket.
Yeah, no, you're right, it is bracket. 3 to -infinity. Yes, good, very good. All right, what about my x-intercepts?
-1.
But is it
No,
-1?
it's like this back.
Yeah, so some fraction or decimal, some value, some not clean value.
0.2 or something.
Yeah. So the question is, how are we gonna find that? So the difference in this test and the last test is, in the last test, if it was something like this, I just told you, don't give it the x-intercept, or actually, the last test, I just made them all nice. But in this test, if you get something like this, I still need the x-intercept. So what am I gonna do to find those values? Yeah, set y to 0. So we know for x-intercepts, the y value is 0. Whatever those x values are, here and here, the y value in both cases is 0. Which means you're gonna go to your equation, make your y value 0. And lo and behold, if you do that, you have an equation that you need to solve. Very much like the equations we were just solving. And that's the whole point of a problem like this is, once you know how to solve these equations, you're on the hook for doing it to find an x-intercept. Let's see. What I want to do really quick is let me give you guys the answer and then I'll, so we only have 5 minutes and we still want to get to this other stuff. So I'll go back and I'll give you guys the answer for this. Actually, so dot, dot, dot. So you're gonna do something to kind of note about this. So again, you could do x minus 2 squared, you could do all that and end up having a factor quadratic formula. But notice that, again, just like example 4, you only have one x there. So this is another one where you can get x by itself. You don't actually need to do anything with factoring or quadratic formula there. So let me just run through it. So to get x by itself here, add 3 from both sides. Let's just do this. -2. And then this extra negative in front, I'm basically gonna divide by that negative. You can think about it as dividing by a -1, but I essentially just wanna flip this. I wanna get rid of this negative. So I'm gonna divide by a negative. I'm gonna do the same thing on the other side. So you can think of it as dividing by negative. But either way, when you divide by a negative or a -1, what does it do to the -3? Just flips it to +3. You're gonna get 3 equals x minus 2 squared. Honestly, as a mathematician, I think of negatives as light switches. You're just turning whatever position it's in, you're just flipping it to the other. Negative means opposite. All right, so now I need to get rid of this squared. How do I get rid of the squared? Take a square root and make sure to include both options. So plus or minus the square root of 3. So plus or minus the square root of 3 equals x minus 2. And then what do I need to do from there to get x by itself? Or in this case, I think add 2, but you got it, yeah. So we'll add 2 to both sides. These are not like terms, the 2 doesn't, well, even if it has square root on it. So basically, these are not like terms. So what I get out of this is x equals 2 plus or minus the square root of 3. Now, if you just give me this is very close to the final answer, but it's not quite. So this is x values, I need x-intercepts. I need these to be ordered pairs. So my x-intercepts then, one of them is 2 plus the square root of 3 comma 0. The other one is 2 minus the square root of 3 comma 0. And again, going back to the comment earlier, I do want exact answers. So this is where if you give me a decimal, you're still going to get credit for most of the problem, but I'll take a little bit off because that's not an exact answer. And then the rest of this you guys can see from the graph. So like I said, the vertex and the axis symmetry are the new things, but you see those from the graph. So what is the y-intercepts? Yeah. So 0, -1. What is the vertex on this graph? Yeah, 2, 3. The axis of symmetry. Yes, x equals 2. Good. Okay, good. There's also going to be, so there's that problem, there's the problems, well, similar to this, but I don't ask you the graph where I give you the quadratic and I just want you to find the vertex. It's a negative b of 2a. So just make sure to look back at one of those problems on homework or something like that. But other than that, that's the test. That's what we'll look at. So I'll see you guys Thursday. I'll actually have something to hand out. That's you. This is it. Yeah, so everyone 5 minutes. Yeah. Well, but if I open that up. They're not functional.
Oh.